Do you know what caused the Titanic to sink? It was poorly designed bulkheads. How can you ensure resilience between different components of your cloud solution? Effectively designed bulkheads, and that is exactly what we're going to be talking about today in this episode of Cloud with Chris. Hello there, and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thank you again for joining. We are in another of the Architecting for the Cloud one pattern at a time episodes. And this time today, I am not lying to you. We are doing one pattern. We are focusing on one pattern today. And we'll be talking all about the bulkhead pattern. So we gave a little bit of a teaser earlier on there. It's all to do with resilience and how you can go ahead and make sure that one application doesn't cause other parts of the application to fall over. So think maybe of different components, for example, or different services, how you can go and isolate those and make sure that one doesn't bring down another. So with that, what we're going to do is we're going to go ahead and jump over to the screen share and take a look at this in some more detail. Okay, so let's just first start off with a bit of whiteboarding for a moment here. So I mentioned in the beginning there that part of the problem with the Titanic, the reason that it sunk, was to do with poorly designed bulkheads. So let's go ahead and just draw our ship, and I am not known for my excellent drawing skills, so I'm just going to put that out there. But imagine we've got a few different layers on our ship here. The problem with the Titanic, of course, you know, the obvious point here is it hit an iceberg, but how the ship didn't stay afloat is quite an interesting point, and it's all to do with the bulkheads. So these bulkheads inside of a ship are effectively a bit like partitions, and you have these partitions so that they segregate the different parts of the ship, so that if one part of the ship gets compromised, then the rest of the ship can carry on as it would expect to and not be impacted. So, you know, it's designed to be able to take some kind of impact, for example, so that it can continue operate as expected and be resilient against that potential failure. The problem, though, with the Titanic was, of course, you know, there was some kind of iceberg that it hit, but the main problem was the bulkheads themselves did not go completely up fully to the ceilings, if I remember rightly. So what that meant is there was a little bit of room where the water could start flooding in and going and impacting the next area of the bulkhead, which eventually then it accumulated so much water and, of course, then was going to capsize and unfortunately sink as it did. And that analogy we can go ahead and carry forwards with us in a cloud world, because what you want is these effectively designed bulkheads so that you don't get this scenario. And I'll just draw this again here. There we go. So you want these effectively designed bulkheads so that if you do get that breach, then it's just that one component that gets, or one service that gets overwhelmed, and not the entire solution, not the entire ship. So that's the analogy that I really want you to kind of keep in mind here as we continue thinking about this bulkhead pattern as we move forwards here. So, the bulkhead pattern. We've really made the point there, it's all to do with resilience. So making sure that we're tolerant for failure across these different components or across these different services within our architecture. So most architectures these days, even if you're going monolithic, will still probably be made up of different services in some way. But, you know, I guess these days microservices is a very typical and popular architecture that you'll see. And you don't want to or rather you don't want it to be the case, or you want to make sure that one service is unable to go ahead and overwhelm another service, for example. So if my shopping cart service gets overwhelmed, we don't want that to impact my basket and my front page website and all these other different bits and pieces. We want them to be isolated in their own way so that they can continue as we would expect. And there's two aspects to that. There's the service that we're actually consuming and the service that we're thinking about there, the back end, if you like. But there's also the clients or the consumers. Now, clients doesn't necessarily mean the end user in this scenario. It might be the end user, they might be talking to some set of APIs or a particular microservice. But ultimately, it could be other services talking to other services. So again, preventing those kind of cascading failures as well. What happens if our shopping basket needs to talk to our inventory service, which needs to talk to our supply chain service, etc., etc. You want to make sure that they are all isolated in a certain way so that you don't get that cascading failure all the way back and impact the end user. They should be able to degrade gracefully there. Now, part of the problem is to do with resource exhaustion, because what happens if suddenly we're, Black Friday, for example, we're running some amazing deals on our site and the website itself slows down? Well, we don't want the fact that the website front page, the catalog, if you like, to impact the rate at which our consumers can go ahead and purchase what they have put in their basket, right? We want to make sure that those aspects are completely siloed and that they're going to carry on running healthily. So that's where resource exhaustion might come into play, for example, because you wouldn't want to put everything on the same underlying infrastructure so that then everything grounds to a halt. You want to have that segmentation and that separation of concerns there and that isolation. So really what we're talking about there is partitioning. Partitioning from, I guess, a logical level, but also based on the underlying hardware that you're deploying onto as well. So think about the method in which you're deploying. You're deploying using virtual machines, you're deploying using containers, is it an app service plan, app services, etc. What is the unit of scalability? What is the unit of deployment from that underlying service perspective? Not your logical deployment, not your service on top of it, but if the actual services themselves start getting overwhelmed, maybe they're using a lot of CPU, using a lot of memory, for example, and they're getting constrained, what does that then start impacting? One of the classic scenarios that I see, for example, not so much these days, but definitely a few years ago when I saw a lot of people moving towards app service, I think a lot of people are clued up on this these days, is app services all share the same underlying infrastructure because they're all part of an app service plan. And that is effectively the infrastructure that you scale up or down. So the slots, for example, in an app service or different app services as part of the same app service plan use the same resources. So as one starts scaling out and really, contending for resources there, what's going to happen? It's going to starve those other services, components of those resources then as well. So think about how you isolate from that underlying hardware perspective, because what you wouldn't want is this scenario where you're starving other services because of the underlying platform that you're hosting on there. Now, ultimately, that partitioning then across those different hardware pieces, you need to think about how you partition across the different logical areas as well. You don't want to tightly couple all of your different services, components, etc., because you don't want to have this cascading failure. If I get a 400 sort of error from one of my downstream services that I'm not then impacted and I can't process and carry on, for example. So it's all of these kind of considerations to bear in mind here. So there's a couple of diagrams, if you're listening in, that I am just bringing up on screen here. The first one is effectively a diagram that shows two different workloads, and the first workload is pointing to a connection pool, and that is pointing to a service called Service A. The second workload then is pointing to two different connection pools, and then each of those connection pools is pointing to its own service, so a Service B and a Service C. And what this diagram is representing is really this bulkhead structure, the fact that you can use connection pools to work with these individual services, right? So if service A fails or there's some issue with it, you're only impacting workload one or the consumers of workload one or the clients of workload one. You're not impacting all of those other clients there as well. And the other way that this can be done, of course, is having each client calling to its own back-end service instance. So really having those each segregated and isolated from each other so that it's going to have a limited blast radius. I've said that term quite a few times on the show, typically focused around deployment and what happens if you get a bad deployment, but same idea here, right? What is the blast radius if something goes wrong? Is it a certain set of services or is it the entire solution? And that's really what you want to be thinking of with this analogy of a bulkhead pattern here. So some considerations to be made with the bulkhead pattern. Defining your partitions around the business and the technical requirements of the application. So, you want to go and segregate those in a way that makes sense logically. You're not introducing unnecessary complexity for the sake of it. Go ahead and isolate and segregate those based upon those requirements. So, availability, for example, and scalability. If you've got something which is particularly sensitive and you don't want it to go down, that's probably a good reason to isolate that from other parts of your solution, for example, so that you start building in some of that resilience that you're looking for. When partitioning services or consumers into bulkheads, consider the level of isolation offered by the technology, as well as the overhead in terms of cost, performance, and manageability. So that's what we just talked about with app service plans, for example. Remember, app service plans is really the kind of the server farm, if you like. So the underlying hardware that you can kind of scale up or down. So if you have many applications deployed on the app service plan, then you're potentially going to see some contention of the resources there. Similarly, if you think about the container space and with Kubernetes, you can use these things like resource quotas, requests, limits. Are you using those types of things to ensure you've got that segregation and that quality of service between those different tenants and between those different containers there? So that's again something as a consideration for an underlying platforming perspective. Now, you also want to consider combining this pattern with some of the other patterns we've looked at before. So like the retry pattern, for example, the circuit breaker, the throttling pattern, because you don't really want to lose that one service and go, oh, hopefully it might come back at some point, right? You still want to have those other, performance and resilience practices in place so that you can go, right, this thing has failed, let's try it again. Oh, nope, it still didn't work. Let's try it again. Still didn't work. Let's try one more time. Okay, I'm going to back off for a while until I know that service might be back, might not be back, rather than just contributing even further to the problem, right? So describing there the retry pattern, the circuit breaker pattern, and the throttling pattern there. The next point talks about when partitioning consumers into bulkheads, consider using processes, thread pools, and semaphores. Projects like Resilience, 4J, and Poly offer a framework for creating consumer bulkheads. So again, that's talking, I guess, about the other end of the spectrum there. And if you're going and calling some of those services, how you can build in some of that resilience as well. So do think about both sides of the coin. Don't just think about the service that you're calling there. The next point I think we've covered, but again, just consider deploying into separate virtual machines, containers or processes. And again, it calls out containers, especially as a good way of partitioning. Now, if you use asynchronous messaging in your application, you might be thinking, how on earth do I do this? How on earth do I use this bulkhead pattern? Ultimately, if you want to start building in some of that segregation, you could isolate that through different sets of queues. And each queue has a set of backend instances that goes and processes messages from that queue. So we're talking competing consumers at that point, and almost like a pipes and filters kind of combination there as well. You could, of course, use a single queue or a single group of instances, but again, you then need to figure out how those instances pull which messages they need. So just think about those pieces, because again, you don't want to start routing messages to the wrong places. So there could be some complexity in there, depending on if you have those asynchronous messaging requirements. But again, just think that through there, because you want to make sure they're segregated if you have those resilience concerns. Determine the level of granularity for the bulkheads. This one's an interesting point. What it says here is, for example, if you want to distribute tenants across partitions, you could place each tenant into a separate partition or put several tenants into one partition. This is very, very common, right? This conversation for multi-tenanted systems from an independent software vendor perspective. So if I'm building a software as a service platform, do I build something like, I don't know, an Office 365 where you don't really see what's under the covers, you don't have your own instance, or do I build something maybe, I can't think of a great example off the top of my head, but something where I can go to chrisreddington.contoso.com where I have my own instance that is deployed for me because of the scale that I as a tenant use compared with the rest of the customer base that are using the platform. And that gives you as a business a great way to be able to go ahead and charge a different costing model then for that particular customer. So they want that premium, they want that extra resilience and that extra scale. They want to be separated into their own deployment stamp, for example. That's great, but they, as a customer, need to be charged for that. So again, that's something differently that you could consider there. And you could compare that model, for example, to like the Elastic Pools versus the single database hosting model in Azure SQL DB as well, and thinking about the costs that you accumulate there as well. And then, of course, just one hopefully obvious consideration is if you are implementing this pattern and you are partitioning, whether it's based on tenant or whatever component or service it may be, make sure you monitor on a granular basis those different partitions, whether you're meeting the SLAs, because that is, of course, what you're doing this for. You don't want to look at the overall picture and look that you're healthy if your main critical service, for example, has been down because you've got a poorly designed bulkhead like the Titanic, for example. So hopefully that makes it quite clear in terms of when you want to use this pattern. Ultimately, when you want to isolate those resources, or rather a set of back-end services across those resources, especially if you want to go ahead and make sure you eliminate this cascading failure and that each of these can operate independently of each other. That's going to be one of those main call-outs there. So protecting against cascading failures and effectively knowing which are the crown jewels of your solution, of your application, right? So not everything is a diamond inside of your solution, someone very wise said previously. So you need to distinguish what are your paperclips, what are your diamonds, and which ones you need to go and protect more than some of the others, for example. Now, it's not always going to be something you want to go and use, right? For example, if this additional complexity is not needed, you don't have those requirements for super high resilience, or if one component takes down another component takes down another, that's actually not a major concern for whatever reason from an implementation detail perspective, then fine. But again, just consider the trade-off of adding that extra complexity versus what that cascading failure may do. And then, of course, because you've got this isolation, you might see that some tenants or some services or some components, depending on how you're partitioning those, for example, might be less utilized than others. So again, you might be seeing a bit of wastage and cost from that perspective if you're looking at it from that cost angle. But again, I would look at it from a way of can you afford to, can you afford not to? So what is the opportunity cost of doing this? What is the opportunity cost if you lose out from this approach? So if you have that cascading failure, what is the cost to the business? And that's really what you need to consider there. And we're not going to go through it, but it does give an example on screen here as well about a Kubernetes pod manifest and using request and limits to isolate between those different pods as well. So hopefully that gives a bit of an idea of this bulkhead pattern and how it fits into the wider patterns that we've been talking about already. Keep that bulkhead analogy from the Titanic or from a vessel perspective, and you'll be going along the right track there. So with that, let's jump back and wrap up the episode here. So there we go. That is the bulkhead pattern that we've just been looking at there. So you know what to do, you know what I'm going to say. If you have enjoyed this content, and if this is a pattern which you were not familiar with, or maybe you were, and we talked about something slightly nuanced, slightly different that you hadn't really considered before, please drop this a like, please drop a comment, or let me know on Twitter, because I love to see how you are using this content, and I love to chat about some of these patterns here as well. So you know what to do. Please go ahead, like the episode, hit that subscribe button, and hit the notification bell so that you know as soon as there is new content. And of course, you may have been watching, you may have been listening in, and if you have been listening in, it could have been on Apple Podcasts, on Google Podcasts, on Spotify, or of course on cloudwithchris.com, where you may have even been reading the transcript as you were listening as well. So thank you again for tuning in. Hope you've enjoyed this session. And with that, stay safe, stay healthy. Very quick episode today. And until next time, all I have to say is bye for now.